Okay, good morning. So let me start with an example. I want to give you an example so that you can think a little bit about that and then try to solve it. Because then, I don't know how many of you have recognized, I didn't upload the last video on YouTube because I thought that we can do a little bit better. So let me just introduce that to you. But before that, I want to use your own knowledge to be able to solve this problem that I want to show. So let's go and turn this off. So here, hopefully you can see a picture. Yes. So I want you to find the function using the information here. I want you to find the function I want you to solve it in two different ways. Write it as a sine function. Find the sine function responsible for this graph, and then find a cosine function responsible for this graph. Yes? So it means that you know what I mean, yes? So, I don't know, write this, y equals to a sine bx plus c plus d. And once more, write it as cosine function. I want to make sure that you understand. I realized that we could do something a little bit better. Of course, A, B, and D are the same. For C, we can do a little bit differently. I want to describe that one to you as well. Okay, so I give you a little bit of time, 5 minutes probably, that you can find these using this information on the graph. Okay, so now let us do it together. First, let us, for example, concentrate on sine function case. So I think for A, B, and D, you don't have any problems, yes? For finding A, do you remember? I think it's good to remember the formulas or learn how to find it if you forget about that, because the formulas are not in the formula sheet. Okay, so what you need to do, what was the formula for A, if you remember? It was y max minus y min divided by 2. And it is clear what is y max. For example, if you look at this point, it is 0.5. And minus, what is y mean? For example, I can take this one, or that one, it doesn't matter. It's minus 2.5. So be careful not to mess up these negative signs. Minus 2.5 divided by 2. So this becomes 3 divided by 2. It's 1.5. You can just keep it as fraction. But anyway, we got A. Yes? Anyone? Problems here? Okay, and then the formula for D was very similar. Was y max plus y min divided by 2, which is 0.5 plus negative 2.5 divided by 2, so it becomes minus 1, agree? So D is minus 1. So probably these are the simplest ones, because you have formulas and reading them is very, very simple. And then we go to B, we need to find the period. Even in the exam, I can just draw up to here. Okay? This is what I want you to learn. Of course, here, it is clear from here to there is one period. You can't see the whole period in the graph, but this is not necessarily, if I want to design another question, I can just stop the graph here. Okay? So then you don't know what's happening here, but you don't need to. You just take one trough and then an immediate peak after that, or the other way around. But remember, this is just half a period. If you do that, you need to multiply it by 2. So let me just use this trick, because sometimes you do not have access to the other part of the graph. So I will take this one, which is, for example, minus 75, and I go up to here. So it is clear how much this distance is 90 degrees, yes? So it means that period is not 90, the period is 2 times 90, yes? So the period is 100. So be careful what we are doing. And then we have a formula which is in the formula sheet. So the period is 360 degrees divided by B. And then what happens? This means that 180, that is the period, is equal to 360 degrees divided by B. Then I can immediately find B. The value of B is 2. And this A, this D, this B is the same, even if you use sine or cosine. The only difference happens at C. Okay, for example, let us concentrate here. The method that I described last time was to you write those numbers. What is A? A is 1.5. And then you have sine. B is 2x. C is not known yet, but D is minus 1. Yes? And I told you that, for example, you can go and find the coordinates of this highest point. For example, if I give 15 degrees, it is supposed to be 0.5. Yes? So what can I do? Instead of y, I put 0.5. Instead of x, I put 15 degrees. Then I realized that we can do a little bit more efficient than that. Yes? But this is not wrong. This is why I didn't publish that. So I multiply this by 15. You have it on Google Classroom, but I didn't publish it on YouTube. Okay? So multiply plus C. And then I have a minus 1. Yes? That is the method that I told you. So you go and find probably the closest peak or trough. It doesn't matter. Then you put this coordinates into the function. And then you see, if I move minus 1 to the other side, it becomes 1.5 is equal to 1.5 sine. If I multiply that, it becomes how much? 30 degrees plus C. And then what happens? This one and that one are cancelled. This becomes sine of 30 degrees plus C. And I told you that this is not unique. You have infinitely many choices for C. So let us, for example, see that if I can find the smallest positive value. If I want to find all possible values, then it would be a little, So this means that 30 degrees plus C should be 90 degrees, yes? Or 90 degrees plus or minus multiples of 360 degrees, yes? So if I want to really write all of them, 30 degrees plus C is 90 plus or minus 300, so let me write plus 360 degrees multiplied by an integer, which is positive or negative. So this is the all the angles, yes? And then you can, of course, here you don't need to find all the angles, but if you move 30 degrees to the other side, it becomes 60 degrees plus 360 degrees times n. These are the all possible values. But usually I'm asking you probably one value, or probably I tell you the smallest positive one, the smallest negative. The smallest negative one doesn't make sense. The largest negative one or something like that. Yes? So for example, if I want to solve this problem, I usually prefer to choose n equal to 0, the simplest case, and I get C is equal to 60 degrees. So this means that C is 60 degrees. So you see, what I told you is not wrong, and it is working. Not that hard, but I mean, might be we can do a little bit better. So it's 60 degrees minus. Yes? That's completely correct. Now, another thing that I want to mention is, let us talk a little bit about this. Yes, we can keep up to here. Good. So here, let me ask you about the graph of sine function. So you know the graph of the sine function somehow. It passes through the origin, something like this, and also continues from this side. This you need to know. The sine passes through the origin. Okay, let us see what happens if I do these operations. Multiplying it by a number, multiplying x by a number, shifting it, adding d to it, so you already know. None of those operations will change this 0, except which one of those? We have 4 operations. Multiplying the function by a, multiplying by x by b, x by b, I don't know, adding c to it, adding d to it, okay? None of them will change this 0 except the shift one. Is that understandable? So, of course, this one also changes all the zeros, you see, because if I multiply b, either I compress it or squeeze it. So, the location of these zeros will change. Yes, if I squeeze or if I stretch or squeeze. The location of all these zeros will be affected except the location of this 0. Yeah, is that understandable? For the sine function I am talking right now. Okay, so it means that if I only consider this function, something is clear. The 0 of this function is, so this graph should also pass through the origin shifted d units. Yes? Is that clear? So because the location of this 0 under the action, of course I made a mistake. This also changes the location because it will shift it. I mean that on the x direction, this will not have any effect. Will not have any effect in the x direction. Okay. So what I'm trying to say is that when you found d, let us call this the guiding line. Okay. And then draw this line, horizontal line that passes through -1. Okay, so let me show another picture for you. This one. So you see, when I calculated, let me make it smaller. When I calculated, when I calculated d, where was d? D was -1. Then for finding c, the next step, another way is to draw this d equals to -1 line, the horizontal line. Yes? And then what you need to know is that the sine function, if I ask you what is the equilibrium line for sine function, if you consider it as a wave, this is the equilibrium line for the sine function. So if I ask you what is the equilibrium line for this green graph, it is no longer the x function, the x-axis. It is this new guideline. So it is oscillating about that line instead of oscillating about the x-axis. So that is the meaning of shifting, yes? Is that understandable or not? And now you can compare what is happening. So compare with the sine function. The normal sine function on the oscillation should start from this point, but now this has started from this point. Yes? Is that understandable? So assume that this point of intersection is your origin. And this is the amount of shift. So you can read it from the graph. You don't need to calculate. It's more efficient. Is that understandable? I don't know. Do you understand what I'm saying? So I'm saying that, yeah, by just, I am changing the equilibrium line in my head from the x-axis, which is normal for the sine function, to this line. Yes? And then I am saying that in the normal sine function, by vertical shift, I will be somewhere here, but now I am not here, I am here. So you see that the normal sine function, which will oscillate here, has been shifted to the left, of course. If you can also think as shifting to the right, but you should be very larger, okay? So the shift should be larger. But here, how much is this shift? You just see that it is 30 degrees, but because it is to the left, C should be positive. Yes? Yes, is that right? So what would be the shift here? The shift, be careful about this point as well. The shift is negative, so the shift is 30 degrees to the left. Yes? Is that understandable? So finding the shift is easy. It is 30 degrees to the left. But if I ask you in this kind of functions, what is the value of the shift? Do you remember we talked about that? You shouldn't say C is the shift. Yes? Because C is not added to X. C is added to 2X. If you want to see how much horizontal shift we have, you need to tell me how much is added to X. Is that understandable? So you see 2x plus c. If I ask you c is added to what? To which expression? You shouldn't say that c is added to x. C is added to the whole 2x. Yes? But I want to know how much is added to x itself. How should I do that? I factor 2 out, it becomes x plus c over 2. So you see, how much is added to x? The answer is c over 2. Is that understandable? Okay. So c over 2 is the shift. Because shift is to the left, so it should be positive. And how much is this shift by reading this? It is 30 degrees. Yes? And then what is c? 60, as we got there. I don't know which one you prefer, but that's also good to know about it. Yes? So the point about this new method is to change your point of view. You need to think about the equilibrium line of oscillation. Yes? The normal function oscillates about the x-axis, but this function is oscillating about the y equals to -1 axis. And just by comparing it with the normal sine function, you immediately can see that this is the amount of shift. And the last tricky part is that you shouldn't get confused and just take that 30 and put it instead of c, because in this case, c is not added to x, is added to 2x. So you need to find how much is added to x, and then you equate them. This is why, if you have seen it in the book, they haven't write it in the way that I have written it. I don't know, they have, in the beginning, from the beginning, they have written it in this form. Something like that. I don't remember the letters that they have used, but so from the beginning they have factored the b out. I didn't want to use it. The reason is clear, because we are studying, of course, we are studying mathematics because of mathematics itself. We are also studying mathematics because we want to learn how to solve problems in other branches of science, and especially physics. And in physics, if you want to write an equation for an oscillator, this is not the way which is common in physics. People write it in this way. A, usually they prefer cosine or sine function, and then you have omega t plus phi. Yes? And that is exactly the same function. This is why I avoided to teach you in this way. Because if I teach you in this way, then when you are studying physics, you need to adjust your thinking. Yes? But if you learn it from the beginning in this form, it would be easier if you want to study physics. So here this omega, which is the angular frequency, is playing the role of this b, and this is the initial phase. And then what is the initial phase is actually the amount of shift. Yes? So this initial phase is playing the role of this one. And then we have A. We do not have D in physics here because we do not have any axis in the first place. We have a wave and then we start rotating. So the equilibrium of that wave, the equilibrium line of that wave will play the role of your x axis. Yes. So this is why I avoided to teaching you in this way. Otherwise you will have problems when you want to study physics. You have to adjust all the time. Of course it doesn't matter. If you understand what is going on, you can immediately adjust. Immediately is not a good word, but you can adjust yourself. And every time you have to think and switch between this picture in trigonometry and that picture in physics. But if you learn it in that way, that would be more helpful. This is the way, this is the reason that I avoid using the notation in the book. Yes. So is that understandable? I don't know. I think this is more efficient probably than the previous one, and actually it is good. Now, what do you think if I want to solve the same problem and write this cosine function? Okay, so let us try to do more or less the same thing. Let me switch the picture. No, I think we can work with this picture because again in the second method I want to have this. Okay, so which one will be affected? The formula for A is the same, so the A would be the same. The formula for D would be the same. Do you think that the period will be affected? No, the period is also the same, so B is the same. So what happens now probably is the only difference is this shift. So you write y is equal to 1.5. This time you write cosine and then you write 2x plus this c that I don't know minus 1. Yes? Again, let us solve it in two different ways. The old method that we described. Okay, so if you want to calculate this as a cosine function, you don't need to be worried. Again, you pick one of these picks and put the coordinates here. Okay? So the coordinates are 15 degrees and 0.5. So let me put them here. So this is the method that we used before. Okay? So let me go up. At some point we will have this intersection. Yes, good. So this becomes 0.5 is equal to 1.5. This time cosine of 2x plus c, and then I have minus 1. I move this, it becomes 1.5. I divide by 1.5, so cosine of 2x plus c becomes equal to 1. Yes? So what is the value here? The famous angle is what? If you want to make cosine equals to 1, you need to be on the rightmost point on the unit circle, which is 0 or any multiple of 360 degrees. Agree? Yes or no? So 2x plus c, if you want to, it is any multiple of 360 degrees that you want to, and is any integer that you like. Of course here, oh sorry, I have to put 15, sorry. So you need to tell me, yes? So instead of this I have to put 15, and multiplied by that it becomes 30, and that's the same thing. So sorry for this mistake. So that is also 30 degrees, and that's also 30 degrees. Okay, so for example, if you don't care about the value for c, you just want to find one value, I would prefer to put 0 here. Then what I get for c is minus 30 degrees. That is not wrong. But if I insist to give me a positive value, then this is not acceptable. So what you need to do, what can I do? I need to go to the next value, which is 360 degrees. And then I move it to the other side, it becomes 330 degrees. So this is the smallest positive one. But from magnitude point of view, the smallest one is this minus 30. Yes. Okay, so let us choose this one if we do not have any limitations. So in that case, the first way will tell me that y is equal to 1.5 cosine 2x minus 30 and then minus 1. This is one way of doing it, and it was right. That is the way that we did it last time. But let us understand now this shift again by this equilibrium line. So the only thing that you need to remember in this method is that the real sine function passes through the origin, but the real cosine function does not pass through the origin. Yes. So what is the real cosine function? The primitive cosine function. The cosine function. So let me change this function to cosine function. So do you remember what was the graph more or less? I hope that at least you remember this. So what happens? So you have this. Yes. So if x is 0, you have 1. So this and then here is how much is 90 degrees. And here is how much is minus 90 degrees. If you go back and review things, you see that this angle is 90 degrees. So the first 0 of cosine function appears at 90 degrees, yes? Okay, now if I want to interpret this as cosine function, again after I found d equals to minus 1, I draw this line, and then, so, now how do you see that? What is happening here? You see again, this is the first 0 for your cosine, yes? But be careful here. So you can interpret it in different ways, of course. You can say that this is also the first 0. So let us concentrate here this time, yes? The normal 0 should be at 90 degrees, but this 0 is at what? For cosine function, this 0 is at 60 degrees. So it means that how much is the shift? The normal one should be on 90. Yes, for the normal cosine function it should be 90. It is not at 90, it is at 60, so it is 30 degrees to the left. Yes, so the amount of shift is 30 degrees to the Yes, the normal one is okay. So it means that the shift is equal to, let me just repeat it myself. So the normal 0 is 90, but instead of having the first 0, I will have my first 0 at 60. So it means from 90 we have moved to 60. So it means that we have gone to the left and the shift is 30. Am I right?
Yes.
So it should be 30 to the left. Yes? Okay, but the same story again here. So now let us go back to the cosine function. Again, if I say 2x plus c, c is not the value that I am adding to x. C over 2 is the value that I am adding to x. Yes? So what you need to write c over 2 is how much? Can you tell me? Yes, is what? 30. Yes?
No.
Am I right?
Yes.
Yes. So then c becomes what?
60.
60 degrees. This we have a problem now.
Go back.
Yes?
If you think
If you take the peak at the 0.5 and it moves 15 degrees to the right,
Yes?
and then if you use that instead, it should be c divided by 2 is equal to minus 15.
No, because if we want to have a criterion that we can use all the time, yes? I
But
don't
it's
want
the
to change
peak.
the strategy. But you are talking here.
No, the peak.
Where? Ah, the peak?
Yeah.
Okay.
It moves
Compare
to
it
the,
with what?
uh,
Ah, okay, I understand. Instead of this 0, you are considering the
Yeah.
peak. That's also good. Yes, I think that's better. Yes, because now instead of considering the 0, you see that the peak. Yes, I think for cosine it is better to consider this peak. Yes, you are right. And I was careless. Do you know why?
Why?
Can you say why? Because multiplying will change the location of zeros. Yes, so be careful about that. So you are right. Yes, I have to adjust myself. So you need to consider, for sine function, you need to consider this vertical line. For cosine function, you should also consider this vertical line. I was wrong. Because if I consider this 0, if I multiply it by b, it will be squeezed or stretched. These locations will change by that operation. But this location will not change. And that was exactly my reasoning, I forgot, yes. So thank you very much for correcting me. So here you are right. The normal cosine function starts from this, so it should be here, but it is not. It is shifted 15 to the right. Is that understandable? So for sine function, consider, always you need to consider this. For sine function, it is here. For cosine function, it is here. Yes? Yes? Thank you. So here, how much it is shifted now? This peak, we're supposed to start from here, but it starts from 15 degrees to the right. So it means the shift, so let me fix that. So 15 degrees to the right. To the right. Yes? Okay. So what does it mean? It means that c over 2 is how much? Minus 15.
Yes.
Because it is 15 to the right. So I should put a negative. And what I get, c is negative 30. Yes? And that's exactly the answer that we have. Is that understandable? Yes or no?
Yes.
But of course you can also use another trick. You can always find sine function and subtract 90 from it. Because then it will change sine to cosine, yes? If you don't like this method. But I want you to understand, you see, what Amanda said actually was good. It fixed my understanding, you know? I told you that the location of these zeros will change, then I didn't respect to my own words, you know, when I wanted to solve the second. So this is correcting me, thank you. So here, this is also a method I want you to learn. I don't know which one you prefer, that's up to you. If you are easier working with sine function, the reason is that when you have a sine function, you can immediately write it as a cosine function by subtracting 90 degrees from it, yes? Why is that? Let me check, not make any mistakes. Because we learned that sine of an angle, yes, is equal to the cosine of 90 degrees minus that angle. But be careful. This is an exception that I can write it alpha minus 90 degrees as well. Why is that? So here we learned before, what is the rule behind that? Complementary angles. If I have a pair of complementary angles, sine of one of them is equal to the cosine of the other one. But here, exceptionally, I can write it the other way around. Why? Yes?
Because cosine of minus whatever you get is the same as cosine.
Cosine of that one. Cosine of minus theta is equal to cosine of theta. So if I interchange them, I will pick up a minus sign, but this will be absorbed by cosine. Yes? So this is why I will be here. If I found this answer, if you're happy, you can just do that. And the good point is that, again, I will give you those questions that you have to write the answers. Whatever, how you get it, that's up to you. So I subtract this angle from 90, I get this. So you can think in this way. I don't want you to do this, but I want you to learn. Otherwise, you can always find sine function and subtract 90 from it. It becomes a cosine function. Yes? Is that understandable? Yes or no?
Yes.
Okay, good. So that is what I wanted to mention. Now I will upload this video, by the way, but the previous video is also on Google Classroom. So now let us go back to today's lesson. I don't know how much time we have. So let me change this angle now. And then let us get rid of this. Another time. This. So you remember we talked about trigonometric functions. We talked about sine and cosine. Of course, the natural step after that is talking about tangent function. Yes, but tangent function is a little bit different from sine and cosine, so you need to be careful about that as well. So let me write the title today. The tangent function, yes? Okay, first of all, there is a very big difference between tangent and sine and cosine. What that difference is? Yes? Yeah, so I didn't mean that, but that's your right. And then what happens for tangent? It can be from any number from minus infinity to infinity. So that's the one of the main differences, yes? So that is one thing. Another thing, we talked about that when I was teaching about the subject of the period of a function. So the normal sine and cosine functions are periodic. Do you remember, is tangent function also periodic?
No.
You should definitely answer yes. Why? Because tangent is sine divided by cosine, and the meaning of period is that the value of the function will return back to itself after some interval. Yes. So then it means that okay, if the sine function is not changed and cosine is not changed, definitely tangent is not changed. So tangent is definitely a periodic function. Yes. For example, I can say that tangent of x plus 30 degrees is equal to tangent of x. By the way, you shouldn't have problems understanding this, because when I say x plus 330 degrees, I will return back to the same point. So both x and y coordinates remain the same, and tangent is the ratio of y over x, so that remains the same. But the point is that if you say the period is 360 degrees, it might be wrong, because it might be possible that I can find a smaller positive number rather than 360 degrees. And I think you yourself answered that, yes?
I just had a question about periods.
Yes?
And if a function doesn't repeat,
Yes?
then is the period 0 or infinite?
No, the period is infinite. Yes, because you don't give a chance to that function to repeat itself. It means that if you want to see the next cycle, it is coming infinitely later. Yeah. Yes. Okay, but now here tangent of x plus 360 degrees is equal to tangent of x. Only this equation guarantees that tangent is periodic, but it doesn't guarantee that the period is 360 degrees, because it might be possible that I can find a smaller value instead of 360 degrees. If I can find that, then I will call that one the period, because by definition the period is the smallest positive number with that property. Yes? Okay, but do you remember we talked about that one as well? So what was the period of the tangent function? Even if you have forgotten, please work on your memories. Okay. Yeah, I will actually try to show you some websites so that it will help you a lot, especially for the people who are in Natur program. They can memorize names very nice. Yes.
I think it was 180.
180. And even if you have forgotten, this is what I'm saying. Of course, it is good to know how to find it all the time, but at some point you need to send it to your memory. Okay, so y tangent of, so this is correct, but this is also correct. Why is that? Because, for example, so by the way, let me change the letter from x to theta so that you're not confused. Because in functions we usually use x, but in trigonometry I will switch later. Okay, so why is that the case? Because if you remember, if I have this unit circle, and then, for example, let us consider an angle theta whose second side, it's the first side of an angle has two sides, yes? The first side by convention is always the horizontal. The second side will be somewhere. So let us assume that the second side is here. Yes? Okay, so, and then let us consider that the coordinates are x and y. But if I add of course, if I add 360 degrees, I will return back to the same point. If I ask you what the value of tangent of theta is, you would definitely answer y over x. Yes? If it is clear that if I add 360 degrees, I will return to the same point, and if I return to the same points, y and x are the same, so if I divide them, it would be the same number. But I can do a little bit better. Instead of going one full round, I am claiming that you can go half a full round. Yes? And instead of reaching to the same point, you reach here, but are the coordinates the same? No. The coordinates would be minus x and minus y. But then again, when I divide them, the minus signs are cancelled. I will get back to the same value. So the period of tangent is not 360 degrees, is 180 degrees. Yes? Is that clear?
Yes.
Okay. So this is one of the differences that matters for the lesson today. Yes, of course, there are the other differences that you mentioned, but one of the differences that matters today is that the period of sine and cosine function is 360 degrees, but the period of tangent function is 180 degrees. Now, let me test your understanding. What happens for the period of this function? It's 90 degrees. Yes? Why is that? Because if you change x to x plus 180, of course, it will work. Let us see what happens. This tangent of 2x will go to tangent of 2 times x plus 180. It becomes tangent of 2x plus 360 degrees. Definitely it is equal to tangent of 2x. So by this shift, I go back, so definitely this function is periodic, but there is no guarantee that 180 is the period, because if I can make it smaller, this smaller one is the period. And as Amanda said, actually this is 90. Why? Because of this factor of 2. Because if I change it instead of this, if I change it to this one, then I will have 90 here, but the point is that after being multiplied by 2, I will generate the one that I need. Tangent of an angle theta plus 180 is equal to the tangent of theta. Yes? So the period is half of that one. And then can you cook up a formula now for yourself? So what is the tangent of bx if I ask you about the period of this function? Yes? Pardon? Okay. Yes, thank you very much for telling me. Thank you.
I'm sorry.
Yes, no problems, but it is very good that you mentioned that. Yes. Otherwise, you will have only half of math teacher. Yes. Yes. Thank you for not dividing me into two halves. Yes. Okay. So, but it was very unpainful division. I didn't even feel that. Yes. So you can be a good surgeon probably. Yes. Yes. So tangent bx. So what is the period of this one? Yes, Jakub?
Oh, wait, a period for it. I just wanted to say that that means that it's equal to tangent of bx plus 180 divided by b.
Oh yes. So the period is 180 divided by b. Thank you. So this is, I don't know if this is in the formula sheet or not, but t is 180 this time divided by b. So you need to be careful if you have that function. So whatever we told about sine and cosine functions, so the rules are the same. Do you remember? So what is happening by multiplying my function by x? The x by b. It will be squeezed or stretched along the horizontal direction. If b is larger than 1, intuitively we think that we should make it bigger, but this is the other way around. We are squeezing it. And if b is between 0 and 0 and 1, we are actually stretching. So the effects are exactly the same. Okay, so something very different from sine and cosine is this number is not 360, it's 180 for tangent. But there is also another main difference between sine and cosine function and the tangent function that we haven't mentioned so far. Can you think about it? That is called, yes, do you want to say something? Anyone else? That's related to the domain of the function. Do you remember what was the meaning of the domain? The domain is the set of all possible values that you can put into the function as input, and then the function can operate on it and gives you an output. That is called the whole set. You know that set theory now. So the whole set of all those values is called the domain of the function. Let me ask you, what is the domain of this sine function? What is the domain of this function? By asking this question, I am asking you, what are the possible values for x that you can put in front of sine and it becomes meaningful? In other words, it is better to think the other way around. Is there any value that I can put here so that the sign of that value is meaningless? No. So it means that the domain of this function is the set of all real numbers. Yes? Is that understandable? So the domain of this function, so let me just repeat. If I ask you what is the domain of this function, you need to think, is there any restriction for the input values here? Yes, and that I cannot put 0. So if I ask, and that is the only exception. So how should you write? Be careful. Now you know set theory. So domains based on definition are sets. So you have to use the language of set theory. So how should you write that? You should write this whole set R but minus 0. This minus is set difference, yes? This is a set. This is another set. You remember set theory? Or you totally forget today? So A minus B means the values that are in A but not in B.
Yes.
So if I want to read this means the values that are in R but not in this. But the only thing here is 0, so it means that not 0. So in principle, in Math 1C, they want to sell this to you, that the domain is x not equal to 0, which is wrong. But that was the best that you could do at that stage. Domain, by definition, is a set. You can write the domain of G is the set of all x's in R such that x is not equal to 0. So if I ask you to write the domain, if you want to pay attention to the details, you have to write this in this way. If you just write this, it means that you understand what is going on, but that is not by definition the domain. Domain should be a set. The range is also a set. What is the domain? The domain, we will talk a little bit about that later, but the domain is the set of possible values for the input that you can put in. And the outputs that you get, you collect them in a set. That set is called the range. Yes? Okay. So now, if I ask you what is the domain of the famous sine function, you say it is R. What is the domain of cosine function? It is R again. Yes? But how they are reflected in the graph? If you see the graph, how do you see that this is more or less? Of course, you cannot see the whole graph. You can always see a part of it, but you can, for example, go to the right and go to the left, zoom in, zoom out. But how do you think that this idea will reflect itself in the graph of the function? For example, this graph, the domain of this graph is not the set, the whole set. One point is not there. How it is reflected in its graph? If you draw the graph of 1 over x, the graph of 1 over x would be something like this. It will continue forever and forever here, and then this will continue forever from here to here. They should be exactly symmetric. I cannot draw them exactly symmetric. So that would be the graph of this function. And this is reflected in the graph. So something happens exactly where? Do I have any problems here? No. Yes? But suddenly something happens when I reach to 0. Yes? The graph breaks out into two pieces. Yes? So I am just when I'm getting close to 0 from this side, I am going to very, very negative numbers. If I am at 0, it is not defined. You see that if I continue this, they will not intersect at all. But then immediately after 0, I jump from minus infinity to positive infinity. So the graph is breaking down. Yes? So this means that the graph is not continuous. I cannot draw the graph of this with one pen stroke, but in principle I can draw the graph of the whole sine and cosine function with one pen stroke without lifting my pen from the whiteboard. Yes? So it's an extremely important concept. So here we say that the functions sine and cosine are continuous, but 1 over x is not continuous. It's breaking into two or more parts, of course. Here in this case we have 2 parts. So do you expect this breaking down things happening for the graph of tangent now? Why is that? Because tangent is a fraction whose denominator is cosine. Yes? So it means that if the cosine accidentally becomes 0, then I have problems. Yes? So let me ask you, if I go and write f of x, now let us talk about this more formally. This is the function that we want to talk. So now here, this can be written as sine x over cosine x. Okay? So, if the denominator is 0, then I will have problems. So it means that those numbers that make the denominator equal to 0 are not in the domain of tangent function. Yes? So if I want to understand those points, I put cosine x equals to 0 and ask myself, what are the problematic points here? But this is easy to answer. Yes? Because you just go here to draw this unit circle. Cosine of an angle is supposed to be equal to 0. And you know that the cosine is the x-coordinate. So where should I be? There are 2 points that I can be for making cosine equal to 0. Either here or here. Yes? So this is 90. And this is 90 plus 180. Yes, which is 270, of course. The reason that I wrote it is clear now. Because now if I go 180 more, I will reach this one. If I go 180 more, I reach to this one. Yes? So if I ask you, what are the all possible values? You say 90. Yes?
Yes.
Plus, can you complete it for me? Yes?
180 and
Yes. 180 times an integer. N belongs to the set of integers, yes? So these are the values that I will face problems. Because it doesn't matter. For example, if I choose n equal to 0, I get 90. I will have problems at 90. Yes? Because cosine of 90 is 0. If I choose n equal to 1, for example, it becomes 90 plus 180, which becomes 270. So it means that I will face a problem at 270. Let me choose a negative value for n minus 1. It becomes 90 minus 180, which is minus 90. I will also face problems here. So if I want to write the domain, how should I write the domain? So the domain of f, we write it as a subscript here. The domain of the function that I am calling it f is equal to the set of all those values in R such that x is not equal to this. Yes? You need to write in words. Might be you are a little bit... So you need to write for some integer q. Integer n, sorry. So let me write it more. So if you want to write it, the domain of f is the set consisting of all real numbers, but with some exceptions, such that x is not equal to 90 degrees plus 180 degrees for, you can write words by the way instead, for some integer n. Full stop and curly brackets closed. So that would be the domain of this function. Oh, sorry, there's an n missing. Yes, is that understandable? Okay, so you know that if I want to draw the graph of this function, I will have problems. Of course, we don't know how to draw the graph that much now. This is the reason that we study derivatives. That's the main reason that people have started learning derivatives, because they wanted to draw good qualitative graphs. And then without derivatives, we cannot do that. But we can do something at least here. So the first thing is that if I have this x-axis, and then this is my y-axis, so let me write it from the middle, because I need to make it a little bit bigger here. So this is the x-axis, and then let me put, for example, 0 here. So let me just highlight the points that I have problems with when it comes to tangent function. So the first positive one is 90 degrees, yes? So at 90 degrees, I will face some problems. The next positive one is how much? 270. I will have problems, yes? The next, so let me make it bigger. So let me make it bigger. So let me take this one to be 90. The next one would be, yes, I will be in problem. This one, and then this one. Yeah. Let us finish here. The reason is clear because I do not have a space, yes? So 90 and then 270, I will go, okay, let us go to negative values. What is the first negative value that I will have problem with? Minus 90. When I choose n equals to minus 1, I get minus 90. So I will have a little bit of problem here. Yes, minus 90. And then I will probably, you understand that minus 270 is another problem for me. Actually, it's better not to study it because it's all problems, yes? We have a lot of problems with tangent. Okay, but what will happen here is that I want to draw something now. This is something, of course, you will study later if you want to understand it better. But here, what I want to do, I want you to understand do you think, I haven't drawn the graph here, okay, but do you think if I go up or down exactly on 90, do you think I will ever get intersection with the graph? If I start from 90, which is problematic, and I go either upwards or downwards, how much you want, it doesn't matter. You can continue forever. Do you think that I will intersect the graph of my function?
No.
No. Yes? No. Why? Because if I find an intersection with the graph, it means that point is on the graph. So it means that I was able to give to 90 to my function and get a value. But I was not able to do that. So something is clear. This is called asymptote. Vertical asymptote. So it means that on these vertical lines, don't look for the graph of tangent. You will not find even single points. Okay? And then on this one as well. Yes? Let me ask you, do you think we need to consider whole picture here, or this part is enough? Yes?
I mean, that part is the time period. So it's...
Yeah, it is exactly 180 this length. So if I draw the graph in one period, because this function is periodic, I just copy and paste it from the left and to the right. Yes? But of course, you know that I will face problems here. I will have problems here. So let us just concentrate between these two things. This one, you don't have any problems. What is the value here? I put 0 to my function. Tangent of 0 is 0. So definitely the graph of the function will pass through this one. Let me ask you another question to test your understanding. Now let me take any random point here, and I will continue forever on both sides. Do you think that I will have intersection with the graph function or not? Yes? Why? Because the only problems are those points. So it means that for this one, I definitely have a value. When I have a value, it means that I should have an intersection. Yes? Otherwise, I will have problems. Okay. So if I put 0, I will get 0. Then what will happen for 90? When I am getting close to 90 degrees, what happens for the value of the tangent? Yes?
Sine is getting smaller and smaller, and cosine bigger and bigger.
Yes.
And cosine is getting smaller
and smaller.
So
yes.
the graph will go up.
So let us, yeah, exactly. So what happens is this. Let me just draw this picture here for you. So here, if I ask you, what happens if I am not allowed to stand on 90, because then I will have 0 for my denominator, but I can be very, very close to 90 if I want to. I do not have any problems. So here, for example, this is my angle. This has y value, x and y values. Yes? And when I go higher, what happens? The x value becomes smaller.
Yes.
But the y value becomes bigger.
Yes.
But tangent is y value divided by x value.
Yes.
This is a fraction. I am simultaneously making the denominator smaller and the numerator bigger. So then what happens to the whole fraction? Do you think it will increase or decrease? Definitely it will increase. So it means that at 0 I am 0, but when I go to the right, it will increase. Increase in positive values or increase in negative values? What? Positive or negative? Because increase means that you can go down and you are increasing. You can go up and you are still increasing.
It should be positive.
It should be positive because we are in the first quadrant.
Exactly.
Yes, exactly. So it means that when I am getting close and close here, this will go higher and higher. Okay? So somehow you need to have this feeling that this is happening, something like this. When I'm getting closer and closer here, it becomes higher and higher. Yes? But now, let us go back here. This time, I want to go in this direction. I want to get close to minus 90 to see what happens. So, where is minus 90, by the way? Here is 0, minus 90 is here. Another name for positive 270. So, minus 90 is here. Now, what happens if I am here? Be careful about that. So here I have this x and y coordinates. If I move towards 90 degrees, what is happening? From size point of view, x is getting smaller and smaller. The x value is getting smaller. But the y value from magnitude to point of view is increasing, but of course in the negative direction.
Yeah.
So this is clear that if I am here, I should be negative. I should get negative values. So it means that I have to go below the x-axis because the value of tangent is negative at that point. Is that clear? But when I get closer and closer to minus 90, the same thing happens. Yes? The y value becomes bigger, the x value becomes smaller. Yes? And then the fraction actually grows up again. But of course, because one of them is positive and the other one is negative, it becomes a huge negative fraction, not a huge positive fraction. Yes? So it means that if I go in this direction, I will go something like this. Okay? And then later, you will learn this, the graph that I have drawn here is not that correct. Qualitatively, we will learn that because we will learn, of course you learn it in math 1C about 3C in derivatives, but you will learn this year that the derivative of the tangent function at the origin is 1. So this is something that we will learn. So it means that the k value of the point of tangency should be 1. So this will go higher, not the way that I drew it. I am giving you this wrong impression. That is not correct. So the correct impression is that this will be in a way that this line is tangent to it. Okay? So because I can not do it with pi. So this is the not real, closer to reality. Yes? The way that I drew it, I gave you this feeling this will lie on this one. Yes? But this is not the case. This should be something like that. Okay, and then what happens? I just copy and paste over and over again. I get the graph of my tangent function. Yes, is that clear? Yes, understandable? Okay. So I think that would be a good idea if I also show you this on Geogebra to see how it goes. Yeah, so this is so small, so let me make it 90 degrees. So let me see, how should I change it? I go here, setting. So, yes, graphics. So I am here actually. So the distance, yeah, I can make this y distance to be 1. We don't need it. Yeah, 1 is good probably. Or even 10 is probably good. Let us see how it goes. This is the x-axis, and then let us go to the y-axis. And instead of making this distance 15, I think it is better to make it 90, yes? Because then we will have a better view. Yes. And then let me put the function y equals to tangent of x. Yes, but that is a problem. Why, do you remember?
What is this?
I'm trying to draw the tangent function. The reason that you see it in this way, because GeoGebra takes it for radians. So you have to change this from here. So you go on the right hand side and then you press this, and that's your function. Okay, so now if I go back, so let me just zoom in to see what happens. So it's actually repeating itself. Yes? And the values are actually, if I ask you, do you think that this blue curve finally touches this 90 degrees, so this line, vertical line? So for example, let me just try to see if I can draw it. Is that right? 90. Yes. So here, you see, let me just zoom in. So this is what I mean. So this black part is not part of the graph. These dotted lines, so I was a little bit careless. I need to draw this as a solid line. This solid line is the graph, but these dotted lines are guiding me how to draw the graph. They are not part of the graph. So you see that in GeoGebra they are absent. But I intentionally draw this myself, x equals to 90 degrees here. So here, x equals to 90 degrees, you see this. My question is that, do you think that these blue curve and this black solid line will touch finally?
No.
No. This is important to know. They will never touch. Or we say that they will touch at infinity. Yes? So it means that this will never happen. Okay? So this is the meaning of something, a line which is called an asymptote. Asymptote is a line that does not touch the graph, but the distance between the graph and the line becomes smaller and smaller when you go farther and farther. Yes? Is that understandable? So that's the meaning of the notion of asymptote. But because this asymptote is a vertical one, so the name is the vertical asymptote. Yeah, is that understandable? Yes?
Yes.
Okay. So I think we stop here, but I will complete this lesson a little bit next time, and then there is a very important lesson of radians and another type of functions, combination of sine and cosine, and then we start the hardest part probably is the trigonometric equation. So what you have learned so far, you need to be able to use that. By the way, when the lesson ends, 11:20? 11:25, so don't leave. We have 10 minutes, okay? Okay, so let me stop this.